Hello. In uh, in this particular lesson, we're going to be covering practice questions for this particular unit that we're dealing with graphs and probability. So on the graphs, we're dealing with circle graphs. Sometimes called pie chart. We're dealing with bar graphs. We're dealing with line graphs as well. And we're going to also talk about probability as we go. So let's start from this particular question here. This question has to do with graphing. So this table shows the number of people employed in the construction industry from 2002 to 2006 in the United States. So A, graph this data and justify your choice. So literally you have several options of the kind of graph you need to make here, or that you can make. So you need to justify the choice that you're making. And then secondly, please provide the advantages and the disadvantages of the graph that you drew. So we can see here that in 2002, there were 865,000 people working in construction. In 2003, it is 906,000 people, and so on and so forth. So we can see an increase from year to year, from 2002 to 2006. So over the span of 5 years. So looking at what I have here, one of the preferred graphs to use here will be the bar graph, because when you're using the bar graph, you get a chance to actually you'll be able to tell from the bar graph the number of people in each group. So, and that's why I'll prefer that one over something like the pie chart or the circle graph here, for example. Alright, so I'm going to go like this. So usually time goes on the bottom. I'm going to have a title here. So I'm going to say construction workers. Construction workers, and so the years go on the bottom here. So the number of people will go here, the years will go here. So I'm gonna do so I'm gonna go with I'm gonna go from 0 and I'm gonna go all the way till about 1200. Actually, what I'm going to do here is because my numbers are between 800 and 1100, I'm going to just do a zigzag here, and I'm going to only go with those. Now, you'll find that sometimes in some textbooks and all that, they actually do that as well. Exactly. So the first one is 865. So that one is going to be here. The second one is 906. That one is here. The next one is 951. So 951 for 2004. 1019 for 2005. 1069 for 2006. Like this. Yeah, and that's it. So please just keep this in mind here. So some people prefer to just do some zigzag here, because as we can see, the numbers are not starting from 0. The numbers are not starting until you are at 865. So some people just prefer to save some paper, save some space, and then start from 800 and then go from there. Whereas some people just choose to still start from 0 and then go up from there. So depending on who you're talking to or the textbook you're looking at, sometimes you may see different forms of this that is there. So the first one is done. Graph these data and justify your choice. Now I've decided to go with the bar graph because the bar graph provides more, shows more clearly the number of the number of people in each category. So that's why I'm doing this. Let me just write that down. So the bar graph clearly shows the number of workers in each year. So that's why it's good to use the bar graph. And then B, the advantages and the disadvantages of the graph that you drew. Well, the advantage we already talked about here. I'm just going to put a check mark. Now the disadvantage. The disadvantage is that we're not able to see the portion or the part to whole. So we're not able to see like the percentage that each one is representing if we want to compare the total number of people like the whole time. It's tougher for us to see how each one relates to the other ones in terms of the percentage, basically. So alright, so it's tougher to see the percentage that each bar represents, basically. Alright, so number 2. Manufacturer A uses this graph to advertise that more than 98 out of 100 of its trucks sold in the last 10 years are still on the road. So we have a bar graph here. We have 4 manufacturers for trucks. Manufacturer A, B, C, and D. Manufacturers here. We have the number of trucks here out of 100. And we have 4 questions here. Now, the impression that we get here, okay, so what impression does this graph give? How many trucks out of 100 are still on the road for manufacturer B, C, and D? Is manufacturer A's trucks more dependable than B, C, and D? Why or why not? What changes should we make to the graph? to make it look more realistic? Well, let's see. From the graph here, I can see that manufacturer A, almost 99 out of 100 of the trucks are still on the road. For B, almost 98 out of 100 are still on the road. For C, almost 97 out of 100 are still on the road. For D, almost 96 out of 100 are still on the road. So what impression does this graph give? Unfortunately, this graph is giving a wrong impression, and this graph is giving an impression that manufacturer A's track record is much better than B, C, and D, just from the height of their own bar, because this one is much higher than B, C, and D. So that's the impression that they are giving. I'm going to say so the false impression they're giving is that manufacturer A's bar is much higher than B, C, and D. How many trucks out of 100 are still on the road for manufacturers B, C, and D? So, for B, so like we're saying, for B is almost 99. So let's just write that for, yeah, I'm just going to write that here. So B is almost 98. So we can see here that for manufacturer B is almost 98 out of 100 still on the road. For manufacturer C is almost 97. For manufacturer D is almost 96 out of 100 that are still on the road. So that's answer to question B. Now question C says that is manufacturer A's trucks, like, are they more dependable than B, C, and D? Why or why not? Well, let's just quickly add here that if we're to compare this to manufacturer A, I'm just going to write that here. Manufacturer A is almost 99. Well, what's the difference between 99 and 98? Just one. 99 and 97, just two. 99 and 96, just three. So manufacturer A's trucks are not much more dependable than B, C, and D. So that's wrong. So they're not much better than B, C, and D, basically. Why? Because there's not a huge gap between 99 and 98 or 97 or 96. It might have been different if we're dealing with, let's say this is 70 and this is 60 or 65 or something like that, or 50. That's a huge difference between 50 or 60 and 99. But there's not a huge difference between 99 and 98 or 97 or 96. So because of that, we can say that manufacturer A's trucks are more dependable than manufacturer B, C, and D. So let's just try and write that down. So number C, A is not more dependable. So manufacturer A's truck is not more dependable. So this is misrepresentation of data, because the height for B is considerably more than for B. Sorry, the height for A is considerably more than the height for B, which is considerably, more than C and D. So what changes can we make to the graph? Well, let's see. What changes? Now looking here, a change we can make to the graph is to start from 0 and then go up. So I think if we start from 0 and then go up, I think it's going to show that there's not as big a difference between each of the four that this one is showing right now. Alright, so manufacturer A is almost 99. Manufacturer B is almost 98. Manufacturer C is almost 97. Manufacturer D is almost 96. Now looking here, this is a better representation of the four different manufacturers, because this one is showing us that there's only a slight difference from A to B to C to D. So this is showing that there's not really a huge gap, so there's not really like a big advantage in going with manufacturer A over B, C, or D. Unlike what this one was showing a huge gap between A and B and C and D. So that will be the change that I'll make to this particular graph. Alright, so question 3. Jesse and James play a game. So they each roll a regular 6-sided die. So we've got a die. It has 6 different sides. So numbered 1, 2, 3, 4, 5, 6. Well, when you count each face, you're looking at 1, 2, 3, 4, 5, and 6. So labeled 1 to 6, find the probability of each event. So find the probability that each player rolls a 6. So A, so find the probability that Jesse rolls a 6. And so find the probability that Jesse rolls a 6 and James rolls a 6, basically. So this is going to be, so the probability will be P of 6 and P of 6. Now the probability of getting a 6 is, well, there's only one face of the 6 faces that is 6, so it's going to be 1. We have a total of 6 different faces. The bottom will be 6. So the probability of rolling a 6 on a roll of die is 1 over 6. So and means times the P of another 6 is 1 over 6. So 1 times 1 is 1, 6 times 6 is 36. So what's the probability that Jesse rolls a 6 and James rolls a 2? So that will be probability of 6 and 2. So which is P of 6 and P of 2. So P of 6 is 1 over 6. So the probability of rolling a 2, well, there's only one face with 2, so just 1. And you have a total of 6 different faces. So over 6. So this is still 1 over 36. See? Jesse does not roll a 4. James rolls an even number. Well, let's see. Well, the probability of not rolling 4 and the probability of rolling an even number. Well, if you have a total of 6 different sides, what is the number of sides that is not a 4? Well, there's only one side that is a 4. There are 5 other sides. So there are 5 other sides that are not 4. So this is going to be 5 over a total of 6. How many even sides do we have from 1 to 6? Well, 2 is even, 4 is even, and 6 is even. So 3 out of 6. So 3 over 6. 5 times 3 is 15. 6 times 6 is 36. So we have to reduce this. 3 is the greatest common factor here. So 15 divided by 3 is 5. 36 divided by 3 is 12. Now this brings us to the end of this question. Alright, so question 4. Amrit writes a multiple choice test. The test has 5 questions. So each question has 4 possible answers. So you're looking at a multiple choice test with 5 questions, with each question having 4 possibilities or 4 multiple choice answers. Amrit guesses each answer. Find the probability of each event. So find the probability that he answers all 5 questions right. So the probability that he answers each question right is this. So P right times P right times P right times P right times P right. Now if you're looking at 4 multiple choice answers, so that means 1 is correct and 3 are wrong. So the chances of picking the one that is right, so there's just 1. The total possibility is 4. So 1 over 4. 1 over 4 times 1 over 4 times 1 over 4 times 1 over 4 times 1 over 4. So the top is multiplying 1, you get 1. The bottom is 4 times 4 times 4 times 4 times 4 is 1024. Now B. So find the probability that he answers only the first 3 questions right. So that means if he's answering the first 3 questions right, then he's answering the last 2 questions wrong, because you have a combination of 5 questions on the test. So that will be P that is right, and P that is right, and P that is right, because remember, anytime is and is multiplied. But now number 4 is wrong. I'm going to say W. Number 5 is wrong again, W. Now whenever they're right, is 1 chance in 4. So 1 over 4, 3 times. Now, for them to be wrong, so if 1 option is correct out of 4 options, that means 3 options are wrong. So that means the probability that an option is wrong is 3 out of 4. So 3 over 4 times 3 over 4. So this is 9 over 1024. So again here, the probability that the first is right, second is right, third is right, fourth and fifth are wrong. So when they're right, there's 1 in 4 chance. When a question is wrong, it's 3 in 4 chance. That's why we have 3 over 4, because you've got 4 options, 3 options are wrong, 1 option is right, so that means 3 out of 4 chances that you're wrong. It answers all questions wrong. So PW, all questions wrong, times PW, times PW, times PW, times PW. So 5 times. The chance that each one is wrong is 3 out of 4. So 3 over 4 times 3 over 4 times 3 over 4 times 3 over 4 times 3 over 4. So we have to multiply all this. So 3 times 3 5 times is 243. And 4 times 4, so 5 times, we have 1024. Alright, so we started from graphing. So we talked about circle graph or pie chart, line graph, bar graph. Then we proceeded to mixed representation of data, and then we proceeded to probability. So we talked about independent events and things like that. So this takes us to the end of our practice questions in this particular unit and in this particular lesson. Thank you.